Things you should know already. You should know how to use the distributive law, how to simplify like terms, and how to add, subtract, multiply, and divide integers. Some key terms. Substitute. You will learn what that means in this video. Simplify. To make something smaller, easier to read and understand. And remember, multiplying integers. When we're multiplying two integers with the same signs, they give us a positive result. When we're multiplying two integers with opposite signs, we get a negative result. Let's say I'm making dinner and I want elbow macaroni. Right? I want elbow macaroni. But suppose when I looked in my cupboard, all my elbow macaroni were finished. Now I have none left. What else could I use to eat with my dinner? Well, when I look, I saw that there's some rice. So maybe I can cook some rice and eat it with my dinner. But suppose my cupboard didn't have any rice in there. Can you think of something that you could use instead of elbow macaroni and instead of rice? Think about it, man. What else can you use instead of rice? Maybe you could use Irish potato, yam, flour, etc. Alright, let's say that we're making some breakfast and we're making tea, right? And I love my Milo. There you go, Milo. But let's say that we never have no Milo. What else we can use? Well, I can use my ginger tea pack. And if we never have no ginger tea pack, maybe we can use some other tea bag or something. And then there's some mint trees outside. I could make some mint tea. What could you use to make tea instead of Milo? Well, I guess you get a good idea. Let's do a few more. Let's say that I love my rice with corned beef. Well, let's say that I don't know corned beef. What could I use instead of corned beef? What would you use instead of corned beef? Well, when I check my cupboard, I see mackerel. So I could use a mackerel. There are other things in the fridge like sausages or even tuna. So there are options that can be used. Alright, one last one. Let's say that I love top ramen. There you go. Don't you like top ramen too? It tastes nice. But let's say that we don't have no top ramen. What can I use to make soup? What would you use to make soup? Well, there's a good old cock soup. It never fails. But suppose we never have no cock soup. What could you use? Well, you'll just have to think about that one. So all these different scenarios fall under the topic substitution. Substitution is really something that you can use to replace something else. For example, we could use the rice instead of the elbow macaroni. We could use the ginger tea or a tea bag instead of the Milo. we could use the mackerel instead of the corned beef. And we could use the cock soup instead of the top ramen. So this is called substitution, where we're using something instead of something else. Let's see how substitution applies to mathematics. Here we have a little scenario. It says, suppose the value of x was 5 in the expression x plus 3. Solve the math statement. So remember, variables, letters or symbols can take on any value. In this scenario, the value that this variable x takes on is 5. So, in this expression, I'm going to substitute or replace or use a value instead of x to solve this expression. Now, the value we were told that we should use was what? Was 5. So, this is what I'm going to do. I'm going to rewrite the expression x plus 3. Now, to show that I'm substituting, I'm going to put the value that I'm replacing in brackets. So I'm replacing x. So I'm going to put the value of x in brackets. Then I'm going to continue with the expression. So I just replaced x with 5. And 5 plus 3? 5 plus 3 is equal to 8. Great. Let's use another value for x. Suppose x was 6. What I'm going to do is to rewrite my expression x plus 3. Then remember what substitute means? It means to replace something with something else. So I'm going to replace x with 6. So if I see x right through, I'm going to replace it with 6. And you remember what we used to show that we're replacing some value? We use brackets. So I just replaced x. But the expression continues by adding 3. So 6 plus 3 will give us 9. Let's look at a little bit more challenging one. Let's look at this expression. 2x plus 3 minus x plus 5 plus 4x, and throw on one more just for fun, minus 2. Great. Now remember, if the value of x is supposed to be 3, it means I'm replacing x everywhere I see x in this expression with 3. So let's go through. There's a 2x here. So wherever I see x, I'm going to replace it with its actual value. And to show that I'm replacing something, I'm going to put it in brackets. So I'm going to have 2 bracket 3 bracket. Is the expression finished? No. When I look, I see plus 3, so I'm following the expression. Then when I look, I see minus. Then do I see another x? Yes, it's right there. So I'm replacing x with 3. Notice what we did. We didn't change the minus x and just put plus 3. We kept the sign and we just replaced the x with 3. That's all we're doing. Are we finished? No? Let's continue with our expression. Plus 5, then plus, and I see 4, and I see one more x. Remember what we're going to do when we see x? We're going to substitute the value of x. And how do we do that? By putting it in brackets. Very good. Am I finished? No, I'm not. I need to throw on this minus 2 just to follow the expression. Great. Can we simplify this? Well, we know that with the distributive law, what's on the inside of the brackets, we multiply it by what's on the outside of the brackets. So in this part, what's inside the brackets? It's 3. What's in the outside of the brackets? 2. So 2 times 3 will give us 6. And I'm following my expression. What comes next? Plus 3. Good. Then minus. What's on the inside of the brackets? Multiply it by what's on the outside. Negative times a positive will give me a negative. And this will be a negative 3. Am I finished? No, I'm not. Following my expression, I have a positive 5 and I have a positive here. But what will it be? I say 4 times 3. 4 times 3 is 12. So I'm going to get a positive 12. Am I finished? No, I'm not. Need to throw on this negative 2. Now, when I'm through, can I simplify the like terms? Well, they're all constants. So I can go through and see 6 plus 3 is 9. 9 take away 3 is 6. 6 plus 5 is 11. 11 plus 20, 11 plus 12 is 23. And 23 takes away 2 is going to give us 21. And that's it. Let's work a few examples together. Suppose A was equal to 3, B was equal to minus 2, and C was equal to 5. Find the value of AB. Now remember, when the variables are etched up beside each other like this, it simply means A times B. And remember, multiplication is commutative. So A times B is exactly the same as B times A. Now, remember, we're dealing with substitution. So we're going to do what with A and B? We're going to replace their values. Very good. So the value of A was what? 3. So I'm putting it in brackets to show that I'm replacing it. The value of B was what? Minus 2. So I'm putting it in brackets to show that I'm replacing it. No. 3 times 2 will give us 6. Am I correct? Because this is not 2. It's negative 2. So a positive times a negative will give us a negative. So our answer is negative 6. Let's try it this way just to prove. What's the value of B? It's negative 2. And I'm multiplying that by the value of A, which is 3. So, a negative times a positive will give us a negative. And 2 times 3 will give us 6. So our answers are exactly the same, which proves that A times B is the same as B times A. Let's look at another example. Here we have 2BC. Remember, when the variables and the coefficients are etched up together, what does it mean we're doing with them? It means we're multiplying. So I could expand this by saying 2 times B times C. I can't replace the value of 2 because the value of 2 is just 2. And I'm following my expression and multiplying it by the value of B. What was the value of B? Oops, it's negative 2. So I'm replacing B with its value of negative 2. Following my expression, multiplying it by the value of C. What's the value of C? Here. So the value of C is 5. And I'm putting it in brackets to show that I'm substituting it. No, these are all constants, so I can multiply them straight across. 2 times negative 2 will give us negative 4, and I'm multiplying that by 5 same way. Negative 4 times a positive 5 will give us a negative 20. Remember now, negative times positive will give us a negative, and 4 times 5 will give us 20. Let's look at another example. Remember the distributive law from previous classes? What's on the inside of the brackets, we multiply by what's on the outside of the brackets. Okay, let's look at it. But first, we can substitute the values for what we already know. What's the value of A? Remember, it's 3. So I can replace A with its actual value of 3. And I'm putting it in brackets. Now, what's the value of C? It's 5. So I'm replacing C with 5 in brackets. Look at that. Following my expression, I have a minus. And what's the value of B? I hope you see that negative. Good. So the value of B is negative 2. Now watch this. This looks like a bag of confusion, but it's actually very easy. We'll start working with these big outside brackets first, right? So I'm going to put back this 3 on the outside here. 5 is just 5 by itself. And look, a negative times a negative right here will give us a what? You guessed it, a positive. So this negative and this negative when multiplied will give us a positive. And I'm going to get a positive 2. Now great. Can I simplify this any further? I could deal with what's inside the brackets here. 5 plus 2 will give us 7. And then I'm multiplying it by what's on the outside. So 3 times 7 will give us 21. Easy, don't it? Let's look at the last one. B squared all over C. Now remember, substitution means to replace something with something else, its actual value. So we need to find the value of B. Well, it's negative 2. So B squared, when I'm replacing B, oh my, when I'm replacing B, I'm going to put it in brackets and show my negative 2. Am I finished? No, because remember, B has on this squared. So my B value must be squared. Then when I'm finished, I'm going to divide it all by the value of C. What was the value of C? It was 5. So I'm putting that all over 5. Now remember, anything raised to the second power means that that thing is being multiplied by itself. So this literally means minus 2 times minus 2. And then I'm dividing that all by 5. Now follow me, now follow me. Negative times negative will give us what? A positive. Great. And 2 times 2 will give us what? 4. Am I finished? No, I'm not. I have to put it all over 5. And there you go. B squared all over C is exactly equal to 4 over 5. Given that B is equal to negative 2 and C is equal to 5. And that's it. Alright, so here we have a question. And it says, solve the expression given that x is equal to some value. And the expression that we have is 2x plus 1. Let's see that x was supposed to be negative 5. And the word given that just means suppose or if. So if the value of x was negative 5, what would this be? Well, all I would have to do is to substitute in the value of x, which would have been negative 5 right now. So, to do that, I could start by rewriting the equation or the expression 2x plus 1. And remember, wherever I see x, I'm going to replace it with negative 5. So I'm going to take up this 5 and replace x right here. Now remember, wherever I'm doing the replacing, I'm going to put what? I'm going to put brackets. Put in a bracket there and put in a bracket here. Now apply the distributive law. What's on the inside of the brackets, I multiply it by what's on the outside of the brackets. So positive times negative gives me a negative. And 2 times 5 gives me 10. Am I finished? No, I have that plus 1 to throw on. So now, I owe somebody $10, but I only paid them $1. Do I still owe them? Or do they have money for me? Well, we still owe them because we never pay up all our bill. So because we owe them, we're going to use the sign that shows owing, which is negative. And how much would I owe them? I would owe them 1 less than 10, which is 9. So when I solve this expression, 2x plus 1, with the value of x being negative 5, I end up getting negative 9. But this time, suppose x was 0, or given that x was 0, what would be the value of this expression? Well, as we did before, we could rewrite the expression 2x plus 1. Wherever I see this x, I'm going to replace it with its actual value. So I'm covering up this x with its actual value. And remember, when I'm substituting, I'm putting it in brackets. Good. Now remember the distributive law. What's on the inside of the brackets, or multiply it by what's on the outside of the brackets. So 2 times 0 is simply 0. Am I finished? No, I have this plus 1 to throw on. So 0 plus 1 will give us 1. So the value of this expression when x is equal to 0 is going to be simply be 1.
Here are some key things to remember. Use brackets to show your substitution. Use the distributive law if necessary. And remember that your signs are important. Don't forget them. And that the order of operations matter.